So one of the things that really excites me about mathematics is a property called invariance. There is a whole chapter on this in one of my favorite books, Problem Solving Strategies by Arthur Engine. It's called invariance principle, but it's such an overarching principle. It's almost everywhere in mathematics and physics, and I'm guessing in other parts of knowledge as well. So one way to look at invariance is that when you are studying a system and a lot of things are changing inside that system, how can you effectively understand that and study it? So that's when you look for something that does not change. When a lot of things are changing, look for what is it that does not change. And that quantity is sort of the magical key that will help you to understand what's going on. That quantity that does not change is known as the invariant quantity. Today, I want to talk to you about one interesting geometric invariant that we are studying now in our mathematical Olympiad program at Jinta, as well as the research programs like hyperbolic geometry or geometric group theory research programs. So this quantity is known as cross ratio. It's one of the most beautiful invariants in the history of mathematics, if I can say so. It was sort of known by Pappus, one of the famous mathematicians of antiquity. He lived in Alexandria about 300 years after Christ. So, and then after Pappus, the next name that comes to mind is Desargues. So he also studied cross ratio and sort of understood the main geometry of it. The cross ratio is something like this. Suppose you have a line and there are 4 points on the line, A, B, C, D. There are 4 points. And then there is an observer point, O. This point is outside this line. This observer is seeing these 4 points, OA, OB, OC and OD. These are the lines of sight, if I may say so. So here is the line, 4 points, and the observer is seeing it, OA, OB, OC and OD. Okay. The cross ratio says something about the observation and the illusion of distance that the observer has and the distance between those 4 points. So if you take another line that cuts through the lines of sight and the points of intersection are A1, B1, C1 and D1, from the observer you have the lines of sight. So you have ABCD on the first line and A1, B1, C1, D1 on the second line. These are the intersection points of the lines of sight with those two lines. Then the cross ratio is a quantity that remains preserved. And what is the cross ratio? Well, AB to CD, the cross ratio of AB to CD is AC by AD divided by BC by BD. AC by AD divided by BC by BD. So it's a ratio of ratios. This quantity remains the same. So A1C1 by A1D1 divided by B1C1 by B1D1 will also be the same quantity. So one way to think about it is if the ABCD are equidistant, like equally spaced on the first line, the A1, B1, C1, D1, though they are not lengthwise equally spaced, to the observer they will appear to be equally spaced, and that illusion is captured by this quantity cross ratio. Whenever you see a geometric quantity or invariant quantity or a theorem maybe, I personally like to make a story out of it. It's my own story. It's how I think about this particular quantity or that particular theorem. It sort of helps me to get one with those ideas at a different level. So anyway, The preservation of cross ratio has been used numerous times in various geometry problems, in mathematical Olympiads, in research problems, and so on. And they have been used to create models of geometry. For example, Poincare, one of the greatest mathematicians of all time, created a disk model for hyperbolic geometry, and the distance function in that disk model uses cross ratio. It's very interesting, and you can read about it. There are plenty of books. One of my favorite books on this is by Monahan. I will put the name of the book in the description. More on these sorts of ideas can be found in 4 Pillars of Geometry. It's another beautiful book. I'll put the name of that book in the description as well. Thank you for watching this video. I would like to share with you my own journey with mathematics from time to time in this series. So keep on watching and let me know what you think. What is your journey with mathematics? One more thing, Chinta also has certain open WhatsApp groups where we discuss mathematics. If you would like to join that and get to know about fun math Olympiad or university level math, or opportunities related to mathematics or physics or computer science, feel free to go to chinta.com and join us via WhatsApp. So there is a link. Click on that link and you can join us through WhatsApp. Okay. Take care and keep on enjoying great mathematics. Take care. Bye.